Hello, and we are live. Hi, so we're continuing our deployment of Langflow in Kubernetes. Getting a little bit more organized today. So we did deploy the Helm chart that we created, a production version of a Helm chart. And now let's just deal with the security issues. So these are some of the things you want to kind of deal with today. So secret key, this is for your API. Langflow uses secret key to encrypt any kind of information, application information. Global variables, these are your API keys from OpenAI, Anthropic, things like that. The admin password, we have to be able to manage the password correctly through our secret manager. We want to test network policies, and once everything's running, we want to kind of start looking at single sign-on, and we'll start deploying OAuth proxy with Keycloak integration. Keycloak is our single sign-on tool that we deploy part of our Kubernetes tools, and we'll try to integrate Langflow with single sign-on. All right, so that's the plan, and we have some time to mostly finish this. All right. So secret key is the first thing. So that thing we just we actually deployed this a few minutes ago. Let's have a look at this. So looking at Langflow documentation, they provide some information how to deal with the secret key, and they use it for encrypting sensitive information within the application. And they give us a little bit of requirements here. It should be this many bytes long. It should be basically for encoded, and it should live in this environment variable. It even provides you a little bit of script here, Python script for Mac and Windows as well, to be able to generate this. Now you want to generate this dynamically through Terraform, and we also want to set the environment variable automatically as well, dynamically through Terraform. So this is what we just did. Let's have a look at this. So what we did is we used this random password resource here to generate this secret key. Now, a lot of times we want to avoid leaking passwords into Terraform state. Now, in this case, it's okay. This API key is less of a security risk when it comes to than compared to credentials, your username and passwords, username and password credentials. And this one, we also want to have the flexibility to rotate this when we redeploy our Helm chart, when we deploy the application. So in this specific case, it's less of an issue of having this in Terraform state. And here we use this random password resource to generate that specific key according to the requirements on the website. And we then squeeze it into Kubernetes secret. So we deploy the secret, and we just set the value here into this variable. And this is the variable. It matches the environment variable. So then we tell a Helm chart to attach secret to the stateful set. Okay, and that's it. So it's as simple as that. So that's deployed. Let's have a look at this. It was just deployed. There we go. So we have our backend, front end, and Postgres database deployed. Let's have a look at the backend. I'm going to come back to these numbers here once we start adjusting the computation resources here. Let's have a look at the deployment. All right. So we have all the environment variables here. We don't see the secret variables here. Let's have a look at the YAML quickly. So if we scroll down, there should be a section here where we have the environment variable here. So keep scrolling. There we go. So this is So these are the variables, environment variables, and now we scroll down here, and there's the secret. Okay. So this is the name of the secret that's supposed to be created. Let's have a look at the secret. And here's the secret. Okay, cool. So it has this secret key is in here, and it's been added to the stateful set. So we're good. Let's have a look at the deployment here. There we go. So this is the front application running. Here's the backend application here, pulling some data. Okay, so that's working. So we have our basic application deployed. It's talking to the backend. The front is talking to the backend. The backend is talking to the database using TLS. So we have a secure communication database. Now the next step is to provide variables, global variables. So if you go to settings and look at global variables here, so we're going to have variables here, and these are your, again, open API key. These are your LLM keys and other global variables you need to run the workflow. And the secret key will be used to encrypt these variables. So that's the next step. Let's add these global variables, at least some of them. Let's just add open API key, Anthropic key, so we can start using them with our agents. Okay. And after that, we'll add the admin password to protect the application and create some users as well. All right. So let's have a look at the documentation quickly. Well, what we need to do for these global variables. So for global variables, what we can do here is we can get them from the environment. Right, so they can be passed in as environment variables. And we have some default environment variable names here. Okay, so we're going to use these names here. The question is, how do you get the key, the actual key into the variable and manage it securely? So what we do is we use Vault to managing secrets, the Open API key, Anthropic key, and all the other keys that we might use are stored in Vault. We use Vault then to, we query Vault with external secrets to create an external secret that then can be used by the pods. So we need to create an external secret and allow the external secret to create a Kubernetes secret that then we can use within the application. Okay, so that'll be the next step. Let's move to the side. So the external secrets are managed by the SecOps team. So let's just go to that project. There we go. Okay. So we're still using Terraform and Terraground, same project structure. This is in a separate repository, so you can protect this repository. You can give it to your SecOps team only. It's not for the DevOps eyes, I suppose. So a separate team can manage this and create external secrets for you, and then you can just consume them within your Langflow deployment. All right, so I'll just create secret. I'm going to reuse some of this stuff here. So we do have LobChat deployed. LobChat is just it's a different kind of Gen AI system, which allows you to query different models. Excuse me. So it's already using Open API key, Anthropic key, I'm just going to reuse the same ones. And yeah, let's do that. All right, so I'll just put it here. So just going, you know what? I'm just going to copy paste a lot of this stuff so I don't have to retype it. And then we'll just customize it. Okay. Let's just customize this. So this is going to go to, it has to go to the Langflow namespace. So secrets are namespace specific in Kubernetes. So you have to deploy it to a given namespace. So we're going to deploy the external secret and the secrets into the same namespace. Refresh interval, I'm just going to keep it at 0. Store name, it's the same store name. We're pulling it from Vault. And I'm just going to give it a different name. So this is going to be used, this is going to be the name we're going to provide to a Langflow Helm chart to consume. Now, before we do anything with GitOps, we always need to create a branch. So let's just create a branch here. So this is in our, cancel. This is in our basic package repository here. So again, trunk-based development, we always deal with master. But when we do development, we create a branch. Atlantis, Langflow, secrets. Now the reason I'm calling these Atlantis is because based on the name, we can do, we can filter, apply different kind of transformation and filtering just based on the branch name. All right. So when we submit this, when we create a pull request, Atlantis will pick this up and execute it for us. Okay, so this is a pull request branch, or development branch. All right. Let's create a new variable. Langflow, oh, no, cursor, no, contains global variables. And let's just set it on map right away to something meaningful. All right, so we have the secret name. Let's go back. All right, you know what? Access code. We can also put the API key here as well, or the API key secret. Have a part of one secret, so let's do that. Let's migrate this over. And again, since we'll be working both projects at the same time, let's just create dev branches for both. So yeah, let's create a branch here. All right. All right. So we have the Kubernetes secret here, and we also have the secret key here, the value that we can generate. Now this can be moved to the other project and be managed by the security team, and also that this secret can now have more than just one variable here, secret variable. We can add the global variables here as well. So we're just going to move this out. So let's get this out of here. Okay. This is not required. And the secret will be generated. So we just want to preserve this key here. So I'll just dump it here for a second, just so I remember. Don't forget this. I'll just put it here. All right. All right, so we can remove this secret from here. It's going to be generated in the other project by external secret, and I'll just come back and replace this with the with the output. So we have to create an output, Terraform output, that we can consume here. All right, let's make this a little bit bigger. You know what? Let me just grab the value so I don't have to retype it here. There we go. All right. So now we have at least one variable. We want to have OpenAI as well in here, and Anthropic, and maybe Survey PAQ. Okay, let's just have those three for us to be able to be used by the workflow on different workflows. We just need to confirm the names from the documentation, the global variable names. So right, so this is OpenAI. Just in case, just overwrite this quickly here. Anthropic, and okay, cool. So the external secret uses these secret stores, which we configure. So the secret store we're using here is Vault. So the external secret dynamically at runtime talks to Vault and extracts this. Now we just have to map these values here to Vault. So the password's not going to require. Let's remove the password. All right. So we're grabbing the OpenAPI key and just remove the client and secret here. I think we're good. I'll just clean this up a bit. Okay. So we're using it for lob chat. I want to use it for Langflow as well. I just like to have different ones for a different project. Yeah, I'm just going to reuse it now and ask the guys to come in and replace this with the key value path to OpenAPI key. We'll create another one on the OpenAI website. We'll throw it into Vault and then we'll just rename it. So right now I'll use it just so we can get going. At least the same one, but we'll come back and replace this. As long as the template, the recipe is done, it's very easy then just to come back and start fiddling with some of these things and renaming some stuff. All right, so right. So I'm going to just leave these lob chat open API key and lob chat anthropic here. These are the keys that we look up in Vault, so by name, and then once we have the name of the the key value pair, the value is the API key in it. So then somebody can just log into Vault, just replace the password, rotate the password, leave the same key name, and we can just use it. So anyway, so this will be replaced once we come back, and we just recheck this. Once we have new open AI and Anthropic API keys, we'll throw it in here and just rename this. But for now, we'll just leave it. So that looks good. Yeah, the namespace is okay. Suki store is good. We have the name. Okay, so the last thing we want to do is create an output, so then we can use it. So in an outputs, Langflow secret name. Let's just call this Langflow global variable secret name. And all right, is that the one? Just to double check. Yeah, that's the one. And that's the one that's going to be created. Okay, good. So we have the outputs. Okay, let's apply these changes. All right, so when we have new OpenAI and Anthropic API keys, the only thing that has to change here is, again, just these two variables here. The rest is still the same, so not a big change. All right, let's commit these changes. Just have a peek at all the changes here quickly, right? We generate the Langflow secret key. We combine it with global variables here. Okay. We create an output that we can use in the other Terraform deployment. And there's one variable. Okay, great. Let's push these changes and let Atlantis do its business. So let's create a pull request quickly here. So this is coming from our basic package when we have all the security tools. Create a pull request. Again, we will delete the branch once it's done, once it's automatically merged. Just do a quick review. All right. Let's apply. Let's see where we messed up, if we did at all. Wrong one. It's taking a while for the Atlantis plan to be executed. This is most likely because of the Vault integration. There we go. That took a while. All right, let's apply these changes here. There you go. So it applied the changes. It merged the pull request into the master branch. So that's we're good. Now let's just see if we actually got a secret here. What did let's refresh this. What was the name of this secret? Where's the name of the secret? Global variables, right? That's what we called it. Okay. I don't see it. Let's just give it a minute here. Well, good. I guess we get to debug this if it doesn't come up in a few seconds. Let's have a look at the external secrets operator quickly, see if it's having trouble talking to Vault. Let's have a peek at the logs. Ooh, whoa. All right, let's have a look at this thing. Okay. Well, we know why it wasn't created automatically for us. So there's a bit of an issue here. So, what is the problem? The Vault backend. Vault backend not found. All right. So before we do anything, we always want to clean up after our pull request. So I'll just switch the branch, pull the master, and we want to delete this branch. There we go. All right. So I want to create another branch to fix this bug. Apparently there's a bug in somewhere. So I'll just okay. And let's just have a look at the code now quickly. What happened? Okay. Right. So when it comes to external secrets and secrets in general, again, they're namespace localized. They exist within namespace. And if you want to have the same secret in different namespace, you got to replicate it, right? Now, the same thing happens for generating secrets as well. So in this specific case, we're using secret store reference. And the secret store needs to exist in the same namespace for security reasons. So we need to add a secret store. And that's the error we're getting as well. So if you look at the error, where is my error again? Right, it's complaining a lot that can't find the secret store. Okay, this is because it doesn't exist in that namespace. All right, so let's add that to namespace. So we have stores here. There's a store. Oh, yeah, I remember. We made it easier to actually deploy between namespaces. Right, so we just got to add a namespace here. There we go. So this is going to deploy one more secret store. Just double checking here. Yeah. And it will get the namespace here. Okay. Namespace here. Using the for each, it will loop through the list of namespaces and just add one more into that specific namespace. Okay. All right, let's create a new pull request. I see you guys are asking about doing this dev in your local environment, something like Kind or Minikube. And that's a valid point. Now, I do like to hit a cluster that is something close to production cluster during dev. And we have several dev clusters up and running, so it's not an issue to using just a namespace to test Langflow deployment. And then you're really close to the production release. So there's slight changes between your local version, your local cluster, and your production cluster. I mean, ingress is one of them. There's several other changes. So the local cluster is amazing for testing of the Helm charts. See if they're fully baked. Testing the interaction between these microservices here as well, front and back end, deploying it there. Also, locally, you're not going to have the same kind of security system like Vault deployed and external secrets. It's just too much to run locally in your local environment. So it's nice to have, the whole thing deployed in your cloud environment, and you can just start using it as you would do for production versus coding a version for your local deployment, which usually would not have Vault and other secret tools installed or Ingress installed. So then you kind of testing something that is not what's in production. So there's a environment parity issue. You want to be as close as production as possible when you're developing. But you can do a lot locally, obviously, right? That's not to say local development is bad. No, it's amazing. It's just us is pros and cons. Okay, let's deploy this. So the external secrets operator has a lot of different custom resources. And that's one of the custom resources that's required. And we'll have a peek at it in a second once it's deployed. Examine that custom resource. There you go. It merged. We're good. All right, let's see if we're still getting these errors. Just going to quickly look at the secret, see if it's generated. Yeah, still don't see it. Let me see if I missed anything else. Let's look at the workloads here. Let's have a look at the external secrets operator logs to see if we're missing anything. Oh, okay. All right. All right. Let's have a peek at this in the log explorer. I don't know. I do prefer doing these things in the browser than in my terminal. It just you can see a lot more than doing kubectl commands. All right, let's see where else we're getting here. So this, oh, they're coming in. So this that's 5 minutes ago. So that's not valid. There you go. Right. So there's a bit of a delay. So these are the old errors. So it worked. We can see the new global variables here. So and we have the secret key here, and we have the global variables that we can now pass in to a Langflow deployment. Okay, so let's do that. So as always, you want to clean up after your you GitOps process. So again, check out master, the usual process, pull the latest code, and delete the branch that you were developing. This is your local branch, obviously the one in the in Git repository was deleted automatically, but this is just your local one. So just proactively, you just want to delete the local one so it's nice and clean environment. You don't get confused yourself. There we go. Okay. Now let's go into Langflow deployment and consume or use that secret that we just generated. Let's put this to the side. Okay. So first thing, we have to make sure if we actually have that remote store configured. We do. It's right here. Okay, so now we can use it to get the name of the secret. So going back to our main. So in our Helm chart, what we did is we give an ability to provide external secrets as a variable, which creates the env from section in your YAML. So in this case, instead of using local secret, we're just going to use the one from remote store. So data. Oh, thank you, Chris. I think we. Oh, didn't know the right one. Data. I just saw on the screen. There we go. All right. Let's just double check with the outputs that we had in the other project. Global. No, that's global variable secret name. That's the one. All right. Okay. So that's it for this. Anything else we have to change here? No, we're good. Actually, let's just let's go back here and just double check. Okay. All right, we're good. Okay, so we're going to come back to these passwords next. Okay, let's deploy this. Let's commit the changes and allow Atlantis to deploy these changes. Just double check. Yeah, so we had the secret created within this Terraform code, and we just had one variable, the secret key. Now it's provided for us by the quote unquote SecOps team, and we can just consume it. And here we have just a remote data store. Okay, so let's deploy this. All right, time for pull request. Deleting the branches always, checking it over again. Yep. All right. Looks okay. Come on, Atlantis. You can be faster. What's happening? There we go. Okay. All right, let's deploy these changes. So there has to be a little bit of a cleanup here. The old secret that we used for the Langflow circuit key should be deleted automatically by Terraform. And the backend deployment should be refreshed with pointing to the new secret that we generated with external secrets. I see the backend stateful set is being refreshed right now. Let's have a peek at the YAML, see if we got the right secret here now. There we go. So these are the Langflow global variables secret that we generated with external secret. We're just not consuming it with this deployment. All right, and that looks good. There you go. It got merged as well. Okay, so let's just have a see if the application is still running. And just go to the root. Hello, where's my application? There we go. All right. So I wonder if we will get the global variables here. Let's have a look. There we go. These are the global variables. I suppose we should delete this one here. This should just add it automatically. I'll leave it for now, just for testing purposes. Just to have two of them here. All right. Yeah. Go away. All right. So we have our global variables here that we're pulling directly from Vault to external secrets. So then we don't have to, manage them. Somebody else can manage them for us, which is inject them into our deployment. And we have secret key as well. Okay. So let's see if we can do something basic here. Let's update. Okay. Hello. There we go. So let's just let's get the output going. Let's use mini. Save some. For me. Okay. All right. I think we're good. Just for basic test. Okay, just checking things over here. Okay, no, we're good. Okay. All right, so let's move on to the next thing that we said we would do, which is the admin password. Right, so let's have a look at the documentation quickly here. Authentication. So we can disable the automatic login that we have right now, which is obviously not good for production. We can set the username, the super username, and the super user password here. Now, obviously, we don't want to set it like this in our, in plain text in our values YAML, and save it to our Git. So we would want to pull this from Vault again. So let's create another external secret that pulls the secret from Vault, and let's configure the super user password in Vault as well. Okay. What else do we need to do? Okay, so that's pretty much it. So once we provide that, we'll be able to log in and create other users. This is just a super user that allows you to create other users. Okay. All right. All right. So it's pretty much unacceptable to have it as plain text like this, right? So we're going to have these variables. We have to inject these variables into a container. We'll do it through Vault. All right. So let me see. If you do it through Vault agent, it might be a little bit more efficient. Now, let's do it through external secrets first. So we'll have it as an external secret. Okay, let's do it through external secrets. We can always change our mind. All right, so we have these two variables here. So obviously we're not going to have them like this here as an external variables. We need to go into our other project and configure Vault. Yeah, let's do this. Let's see how much time we have. At least we can start this. We can kick this off, and then if we have those secrets, we can just redeploy Langflow quickly. So in our case, what we want to do is first we want to create a secret in Vault. Now we'll do this through again through GitOps, not through the GUI. So we have we can look at it as code versus having it just in GUI. So in our Vault management repository here, we'll just add let's see. Let's use a job. So we'll do this at runtime. We want to deploy a container that will talk to Vault and configure it, grab a password, so then it's done at runtime, and we don't have to store anything locally. So we'll just create a Vault job, Kubernetes job that will query Vault, set up the password, and then it will just end. And then that means that again it happens at runtime versus having it here in code. Okay. So let me just grab one of these things here quickly. So is this your Grafana password, key code password? So we have all different passwords here, jobs that we execute, and again, we don't have to have it in code. All right, let's just grab this Grafana password as an example. So Grafana dashboarding system that comes from Grafana people has an admin username and password as well. So same idea here, Langflow. So Langflow admin, ID admin user. Okay. Langflow ID, admin password, perfect. So here we're using our own module. We created our own kind of Vault job module that kind of allows us to kind of quickly build these jobs. I might share that after the site. I most likely will share it. All right. We just need to give a name. This is the name that we're gonna use to compose the name of the job. Langflow ID admin credentials. We also have our own image here as well. Namespace. Let's update the the namespace is going to execute this in a security namespace, so then it will just directly talk to Vault. It doesn't have to have additional credentials or secrets that we need to replicate in different namespace, so we'll keep it in the same namespace. The other stuff is all good. It's just Vault TLS communication set up here. Now create password here. This is a script that we created that creates a password based on our policy. The policy that's also defined in Vault. So it's just a little bit of script here. So this is it's a template right now, and then that template is going to get created, converted to a script. So if you look at this, create password here, it's a bash script, and you can see the double dollar signs here, which means that it gives you a clue that this is a template. So it's going to get converted to a single dollar sign when the bash is executed. So there's just is how you want to escape things in for Terraform template. So then we can inject, like here, we're injecting variables from Terraform variables, and then we can just execute this as a bash script within our job. Okay, so this looks good. And these are the variables we need to add. Okay. So the password policy, we're going to use the same password policy that we have in a company as a standard that we configured. That's already part of Vault. So we're just calling it by name. And what we need here is define this thing here, which is our additional argument here. So let's just get this updated specifically for Langflow. Where did I put it? So I'm going to call this Langflow admin. All right. This is what we're going to expose to our external secrets. Okay. And let's do that right now before we forget. Oh. All right, good. So once it's created, we can use this key value. It's just a path, so it tells you where it is in Vault in a key value engine, Vault engine, secret engine. And then we can use this to as a reference to when we create an external secret to talk to it, to grab this specific password from here. All right, so that's good. What else do we need? We're good. Let's just have a look at the job. Now, again, we're doing GitOps. So let's clean up this branch and then also create a new dev branch for pull request. All right, so delete this. This is going to be Langflow admin credentials dev branch. Okay. Okay, so I think we're good. So the job is good. The name is good. We'll execute the password job, the specific script here. Has all the credentials, the certificates, talk to Vault. All right, and additional arguments here. Good. Okay. All right, let's push this. And also we have an output for external secrets. Great. All right, let's create a new pull request. Let's just review this quickly. We have a new local variable. Now that's the name of the key in Vault. We executing new job. Okay, and we have an output for the reference to the key name in Vault. Okay. Again, this just kind of follows this zero trust approach that we take. We're pushing everything to the cluster, the tools in the cluster, the password manager, the secret manager, the certificate manager. All these different tools are within the cluster. So the job there, is deployed and does its thing within the cluster, within the same environment. So we don't have to leak the credentials outside the environment, and it creates it for you. So again, it's about zero trust approach. Also, not storing credentials in Git, avoiding the sprawl of secrets. Now, what's interesting here is that we have a lot of plugins in Atlantis to help us kind of identify issues, right? So in this case, TerraScan is running, and it says that we violated a policy. Okay, so I'm just going to have a look at this quickly here. Which policy? So now these things here are valid except for this specific use case where we're deploying a job that requires some high level of access to Vault, and also it looks to me that maybe it's time for update the job as well to update the security context. And right, so we'll have a look at that. And there's another check here. This is from Chekhov as well. Gives you a little bit of feedback here. Tells you what's happening here. So some of these things are minor issues. There's nothing critical I see here. Quickly scrolling through it. Right. Okay. No, we're good. So there's nothing that needs to be fixed right away. And these are just minor issues, mostly hygiene issues, I would say, when it comes to the job YAML that it's generated. All right, let's see if the job gets executed. So it's in a security namespace. There you go. There's the job running right now. Oh, it's pending to be executed. Now we have a little bit of logging on this job. Oh, it's already done. That was fast. Let's look at the log. Now it should be minimal. We don't want to leak credentials into the logs. Let's see what we have in this log. If there's anything in this log, come on. What's going on, Google? Why is this slow? All right, well, that's extremely slow. All right, let's open this in the Log Explorer. Maybe get. If there's no log, that's great. We don't have any logs security, but I was hoping there'd be some logs I can have a quick peek at, see if everything was successful. And just, all right. If that's the way it is, that's great. You guys did a good job. It's a very sensitive job. You shouldn't be leaking any credentials here. I'm going to change the time quickly here today, just in case it's a time issue. No, okay, good. Well, that's good. Okay. I'm happy with it. All right. So the job executed. There you go. It's done. Successful. Great. And pull request must merge automatically as well. Oh, good. Let's go clean this up. The next step is to create an external secret that we can then pass to Langflow with the username, the admin username and password. Let's delete this. All right, now we're going to do in the same branch. So external secrets operator is in the same project here. So Langflow admin secret. Okay. So we have this output here. So this is the output we'll use to grab this secret from the from Vault. All right. I'm just going to create in the same spot here. There's going to be my Langflow section. Actually, maybe we should. I wonder if we should put it here, just to have the same secret. Why not? We can. Yeah, let's put it here, so we can just use the same secret. All right. All right. So let's just have a look at documentation quickly. So we require 2 additional variables, Langflow super user, all right. Oh, come on, cursor. Don't be difficult now. Okay, and we need one more for super user password. Oh, that was painful. Okay. Yeah, that simplifies things. We can squeeze into the same secret, and it's already wired, so it just requires a refresh. All right, so we can define our own super user username. Right, there's no requirement on that. They have as admin. I'm just going to put Kubernetes in here. And what happened here? Now for the password, this is where we use that output from a Terraform. So we're going to add just one more. I'm just going to grab this quickly. Now the secret key is the key that is used within the target. So in here, I'm just going to say super user password. Okay, and now for the property and the key, we'll be using properties password. That's based on the script. We can just actually double check this quickly. So if you look at the script that was used to create this, yep. So key and password are the two, I'll call them data keys, which is here, password key, those two here. Right, so yeah. Hold on, does that make sense? Data key, what's the data key? Yeah, it's password, sorry, it's right here. Wow, I forgot even what we did here. Okay, so yeah, so the password is the key, and the password is the key for the password. Okay, so going back here, password. Now we just need to get this output here. I'll just move this up. Let's call this Langflow super user credentials. And I'll just define this at the top, just so easier to find it. Let's put it in, what's a good section? Here. Thank you, cursor. That was helpful. So let's see the output here. Where's not this output, the output from the job here. So okay, we can grab this one here. All right, cool. The comments here. Let's fix the spelling mistakes of Langflow. Okay. All right, we're good. So if we scroll down here, because I know we made a spelling mistake, so we can't find it here. All right, so that should be enough to create a super user password here, pulling it from Vault that was automatically generated. I don't know what it is. I don't care to know what it is. I don't need to know. As long as it's it passes all the way from Vault to Langflow. Nobody needs to know what it is. In fact, it should be secret. Okay. All right. Looks good. Looks good. Okay. Let's deploy this. All right. Time for pull request. Again, delete the branch when we're done with auto merge. Quick overview. Yeah, we have a username, user password that we're pulling directly from Vault. All right, let's create a pull request. Still running the Atlantis plan, Terraform plan. It's taking a while. I guess we have time to play with Grok 3 or Claude, maybe 3.7. Ask it to do some coding for us. There we go. All right, let's apply this. So this should rotate the secret automatically. Since the external secret operator manages the secret, it should delete and create a new secret. So it should go through this reconciliation loop within the operator and see the difference between secrets and just delete one and recreate it. There it goes. That's merge, done. So let's have a look at the secret now. So if you go back to Langflow namespace and look at the secret, there we go. We have the new variables here. Super user now, again, they will not be picked up by the stateful set backend deployment because you have to refresh the deployment for the new changes to take effect. So let's just make that big. You can see the reconciliation loop running here in the operator and just create a new one for us automatically. Well, it refreshed it. It was created way before, but just refreshed it for us automatically. Okay, so now the next step is to, well, we don't have to do much with Langflow anymore as long as we restart the container. But I do want to add one more property on the stateful set deployment to automatically trigger refresh when the secret is updated. So let's do that. Okay, so let's just go and create a new branch, dev branch. So this one is done. Again, let's clean this up. Check out master. Pull the latest code. And again, we just delete our local branch so we don't confuse ourselves in the future. So a nice clean environment. Okay, cool. So now let's create a new dev branch and a Langflow Terraform deployment here. So, and we just do a minor change here. So secret refresh. Okay. Okay. So we're using a specific tool. It's called the reloader, and it's an operator. It checks for specific annotations on the deployment, and if a secret changes and the deployment has that, or stateful set has that specific annotation, it automatically refreshes the deployment, so it picks up the new secret. So what we want to do here is update the stateful set annotations. And there we go, stateful set annotations here. And let me just grab the exact, actually I have it here, Postgres. So we did it here as well. This is when the TLS is refreshed. So where is it? Here. Okay, so there. Primary annotation. Right, okay. So I'm just going to grab this. And let's add this to our values here. Now let's put an NMA. So this should be part of Terraform here. So I'll add it as another variable, local variable. Let's call this annotations, backend annotations, stateful set. Oh, thank you, Cursor. That was nice. Nice of you. All right. Okay. So let's just grab this here. All right. So this basically, once you have this reload annotation here, the reloader checks for this annotation and then also checks for the secret. So let's just put the secret name here. So in our case, the secret name is this one here. So when we change anything in this secret, this will be, there we go. What do they do? Okay. Let's just double check this. So stateful annotation. Let's deploy this. So the idea here is, again, any changes to this secret where we have a password, secret key or global variables. Anytime we change this, it's just going to automatically refresh the backend stateful set, the backend deployment automatically. So think about it. All right, let's push this. Oh wait, I need to add it to the values. Hold on. So once you define this, little piece of YAML here, values YAML, you want to add it to your local, and just to be, just to clean up, just to be mindful of the hygiene factor here. We're gonna go back and remove it from here because now it's part of the Terraform. All right. All right. All right, we are good. Local backend stateful annotation. Okay, let's deploy this. All right, I guess we have time for one more pull request. All right, quick review. Hold on, these tabs don't look good. All right, let's cancel this right now. Let's just make sure that the tabs are okay. Yeah, let's tab this over. All right, let's try the pull request again. Yeah, it's looking better now. All right, let's create a pull request. All right, let's apply. Let's deploy this Terraform code. So the only thing that should happen is the backend stateful set should be just refreshed. Oh, let me see. That's interesting. Oh, okay. All right, let's explain this. So the update strategy on the back on stateful set is that you have to kind of delete it, delete the pod. So when it comes to stateful sets, or actually any of these Kubernetes deployments, you can set the the update strategy. The strategy is to update your specific pods. So you can see here the annotation was applied, but if I look at the managed pods, the annotation is not there, right? This is because of the strategy that we use. So I'll show you the strategy here. So if I look at let's go to the YAML, and let's look for the strategy. There we go. So here's the rolling update here, right? This is the strategy here. All right, so I can just manually delete this quickly here, and maybe we'll update the strategy here to respond to such changes. Anyway, so we're here in the pod right now. We can just delete the pod, and when it creates a new one, it should have the new labels on it as well. Let's give it a second. And what should happen? What's the expectation here? When we go to Langflow application, we should have, this should ask us for credentials to log in, super user credentials. Let's give it a second to refresh. Still deploying. There we go, done. Okay. So let's see if my expectation here of the outcomes is good or not. Where is my credentials, super user credentials? Let's double check if these variables are okay here. Yeah, super user. Oh, auto login, right. So this is, I'm looking at their chart here. So the auto login has to be set to false. Otherwise, it automatically logs in for you. Okay, so let's do this as the last thing. We have a few more minutes here. So let's just get back to our deployment here. Again, let's clean this up. Let's delete this branch. Create a new branch. Let's call this auto login. All right, so let's have a look at the code quickly here. Right. So we're going to set this to false. Okay. All right, time for a pull request. Let's double check this. So it's false with capital F. So these, I'm assuming these are Python properties, because in Python it starts with capital F. Oh, they capitalize the Boolean values. So that makes sense. There you go. All right, let's apply these Terraform changes. All right. There we go. The backend is refreshing now. I might give it more resources. It's just taking a while to restart. Let me look at the resources here while it's refreshing. All right. So we gave a half a CPU, and it's using almost the full thing. And the limit is 1 CPU. All right. We can definitely reduce the memory here. So we'll come back and fiddle with these later. It just seems too much. But it's not being used right now, right? So we'll put on the stress and then see if 2 gigs is too much. It's running at 750 megs right now. So, yeah, that's that's so far away from 2 gigs. All right, let's see. So my expectation is the auto login should be disabled now, and it should ask us for your admin user. There we go. Beautiful. Okay, so let me look at the slides here just to keep myself on track. So we did this. Let's change the colors here. Highlight it. We did this. We did this. All right, so we need to test the network policies. So I like to test network policies after I have a good, stable, deployment with some of these function requirements fulfilled, like setting up some of these variable secrets, so I know it's working. So then I don't get a false positive when it's the password and not networking, right? So next thing I'm going to do is next session, just enable network policies on both the front and the back end, and we're going to try to kind of get into it with another container, see if if the policies are solid and well configured, and then we'll start looking at single sign-on. So right now, Langflow has this username, super username, and password here to log in, but we want to have a single sign-on, right? So we want to manage your credentials, somewhere else, and then pass these credentials down to Langflow, and then move that the whole authentication authorization piece out of Langflow, move it up to Keycloak. And so we'll do it progressively. We do the authentication or the OAuth proxy first, where we'll protect this endpoint, this public URL with Keycloak first and credentials. And then we'll see if we can, find a way to move that GWT token that comes from Keycloak into Langflow. We might have to fork it. We'll go on. If we have to recode, we'll change the Langflow code to Python backend and front end. We'll fork it and add single sign-on to it. And that's it. Anyways, we're ending here. Thanks, guys.